So now we will explore the VLAN, the virtual LAN. We'll deep dive into the Cisco VLAN technology. What is the VLAN? What do you mean by the virtual LAN? Why is it so virtual? And where is it used? Because we know that LAN is a broadcast domain where all the pieces are communicating with themselves. That is a local area network or LAN, and VLAN is a virtual LAN. So it means that it is not so real because in a switch, if you consider, then it is the same LAN. But if you logically divide these LANs, then it will be the virtual LAN. So let's deep dive. So what is a VLAN? VLANs are essential components of modern networking that allows for logical segmentation of networks. This is the key point that you are doing the logical segmentation. You are segmenting the network. Means like subnetting. In subnetting also we segment the network. So that way you are segmenting your network. That is the reason why you are creating the virtual LANs. You do it by isolating the broadcast traffic, enhancing the security and improving network management. So VLANs actually play a significant role in optimizing the network performance. So what you do if you have too many PCs, so it will get a lot of broadcast traffic. So what you can do, you can regulate the broadcast traffics by segmenting the networks, means putting the network in different segments or different logical parts of the network. That way you can create the VLANs. So what is a VLAN? A virtual local area network or VLAN is a logical subnetwork that actually groups together a collection of devices from different physical LANs. So let's say different PCs you can group together in a VLAN. So let's say it is in the 10.0 network or 20.0 network. That way you can group the pieces together. So this is the VLAN, and VLANs function by tagging Ethernet frames with identifier. What does it mean? It means it tags with the identifiers of the VLAN numbers. So it tags with the numbers, and it allows the network administrators to manage and segment traffic efficiently. So it actually reduces the broadcast traffic and it optimizes the performance. So what are the benefits of using the VLANs? First of all, improve network security. How? Because you are segmenting the networks, and not only you are segmenting, you are having a router. So if you are having a router in place, you are connecting a router to the switch, so you can configure ACL, access control list. That is a security measure in the router. So you can actually prohibit the traffic from one VLAN to the other VLAN. So that way you can incorporate the security. So VLANs improve network security by isolating sensitive data and devices within specific segments and making it more difficult for unauthorized users to access. Enhance performance. So you can, by segmenting network traffic, VLANs reduce the amount of data actually transmitted across the network. So the volume of the broadcast traffic is segmented or it is channelized. Like there is a street, like open street, there is no lane. Then the broadcast traffic is more. Like if you have created the lane, you have channelized the traffic, then the volume of traffic or the volume of broadcast goes down. The same way VLANs act, leading to increased performance and faster response times. Then simplified management. VLANs simplify network management by allowing administrators to organize and manage devices based on their function rather than the physical location. So VLAN can spread across different regions. It can spread across different globes. The entire globe can be a VLAN. So you can have different cities together as a single VLAN. That is possible because it is related to subnetting. It reduces the broadcast traffic. So VLAN significantly reduce the broadcast traffic by actually confining broadcast domains. So you are actually regulating the broadcast domains. You are making it smaller in size, and so which helps in minimizing unnecessary traffic. So what are the types of VLAN? We have data VLAN. Whatever we create, that is a static VLAN. So according to the function, it is say the static, how you configure, or dynamic. Now, dynamic VLAN is created on layer 3 switch only, and you need a special application that is known as VMPS, VLAN Management Policy Server. where you put all the MAC address of the device or the PCs, and the switch automatically puts the PCs in respective VLANs. So whatever you create according to function or working principle, that is the data VLAN, and another is the voice VLAN. Voice VLAN prioritization means that voice is given the most priority, and voice VLAN means that where you connect the VoIP supported devices or the voice over internet protocol, that is the voice VLAN. Management VLAN security. Management VLAN means you are having one native VLAN, that is the VLAN 1, that we call as the management VLAN, that is already there in the switch environment. So you cannot create the management VLAN. And native VLAN default role, that I've already told you that native VLAN is a VLAN which carries the unencrypted data traffic. So these are the theory parts behind the VLAN technology, and now we'll dive deep into its configuration. So for that, let me take you to the Cisco packet tracer now, and I will take a switch. So this is a switch that I have, and I will have two PCs. One will be in VLAN 10, another will be in VLAN 20. So you just connect it. This on F0 by 1, and this one VLAN 20 is on F0 by 2, and you have the routers. Say first in the 0 by 0, you connect it to 0 by 3. And now you make the VLANs on the switches, CLI, VLAN, say 10, name, say CCNA, exit and come back to the config mode. VLAN 20, name ZNP, exit and come back to config mode. And now place the PC in respective VLANs, say interface F0 by 1. I think it is connected to the F0 by 1. Yes, it is indeed. And then you have the switch port mode access is the command to make it an access port. That is the port that is carrying the untagged traffic, that is to the VLAN 10 only, the connected connection between the switch and the PC. And switch port access VLAN 10. Then interface F0 by 2, switch port mode access, switch port access VLAN 20. So these are the two VLANs that's created, and it is attached to the F0 by 1 and F0 by 2 ports. Then you have a router here, so we'll trunk this port F0 by 3. So interface F0 by 3, or rather, I have not entered. So enter again 0 by 3 and switch port mode trunk. You do not need to actually configure encapsulation because it's auto sensed. And now the main part, you have to configure the interface VLAN 1. That is a native VLAN. You have to give an IP address, and also you have to define a default gateway. Now, what would be the default gateway? Default gateway would be the IP address of the router. So interface VLAN 1, bring it up with no shut, and IP address 192.160, let's say 10.1, and I'm giving the default mask, any mask can be given, and IP default gateway. For example, it's 192.168.10. So 10.10 will be the IP address on the router. So this will be the configuration on the switch, and on the router we'll configure the router on a stick. Means the router has only one Ethernet port, but you will configure different IP addresses. Now why different IP? Because router will be having one IP address like 10.10 that we have specified as a gateway. Also, it should know the default gateways for VLAN 10 and VLAN 20, that would be, for example, 20.10 and 30.10. So on router, you are having only one physical interface, but how can you configure three IPs? So in that case, you have to configure router on a stick, means you have to divide the router's physical interface into sub interfaces or logical interfaces. Let's do that. So on router, you have this physical port, F0 by 0, sure, but you are not giving any IP address here. You are giving interface F0 by 0.1. That is the first sub interface. In cap .1q, there is the encapsulation 802.1q of the IEEE we have. So that is the .1q encapsulation, and it should match the sub interface number, that is 1. And the IP address, it should be the one configured as the default gateway on the switch 192.168.10.10. So that is the IP address of the router port. And now next one is F0 by 0 dot. Now we have created VLAN 10. So that is why it will be F0 by 0 dot 10. This sub interface number should match the VLAN ID. This is very important. And encap dot 1q space 10. And the IP address, for example, let's say it is 20.10. That is the default gateway for VLAN 10. And interface F0 by 0 dot 20 for VLAN 20, and also in cap dot 1q and 20, and the gateway will be 30.10. So this is the entire configuration on the router stick on a router, and we have configured the switch also. Now let me give the IP address on this VLAN 10 PC. It should be in the 20 network. So 192.168.20.2, and default gateway would be 20.10. And here 192.168.30.2, and the gateway would be 192.168.30.10. So I put the IP addresses and now just ping between the VLANs or the inter-VLAN routing. So ping and the 192.168.30.2. So one ping will miss for the R, and then we should receive the reply. And yes, indeed, it is pinging. And also on the other PC, if you go on this PC actually 20 rather, ping 192.168.20.2. So this is the way the inter-VLAN communication is happening through this router. So what is happening? This VLAN 10 PC is communicating with 20 or 20 to 10, and the switch is forwarding traffic to the router, and the router is seeing the default gateway and it's recognizing the VLAN ID and is forwarding to the other VLAN. So that is the way the inter-VLAN communication is done. So that is the deep dive on the VLAN technology that we have got, and I'll see you in the next chapter.